Hello students, in this video we are going to discuss about the block diagram reduction technique which is used to find the transfer function of a given system. So let's start. We may have different types of a system. It may be a mechanical system, it may be a thermal or maybe a liquid level system. So if we are having a mechanical system, it consists of mass, that is M, then we will be having an energy storing element in the form of spring represented by its stiffness K. Then we may have a damping element normally represented by damping constant C. It is a energy dissipating element. So if we are having this kind of mechanical system, if it is applied by or acted by some force, we always interested in finding how this mass is moving, or what is the velocity of this mass, or maybe what is the acceleration of this mass. So if I'm having this kind of a system, what we can do, we can directly see or determine what type of physical law this system is following, and based on that we can determine its equation of motion. So once we have applied the physical law that it is going to follow, we will be able to determine equation of motion. And after that, what we can do, we can apply Laplace transform in order to obtain its transfer function. Like here, if we are having an equation of motion of this system, then we can find what is x of s upon f of s, that is output upon input. So this will be your transfer function. So this is for mechanical system. Similarly, we can have thermal system also. So in thermal system, mainly we have to determine what is thermal resistance and thermal capacitance, and based on both of those terms we can determine what will be the equation for that system, and again by applying Laplace transform we can get the transfer function for thermal system. So if we see this mechanical system or thermal system, it may be a simple one, but what if we are having a system which consists of number of elements, and maybe those elements are from different field. So in that case, directly determining transfer function for a given system is not a simple task. In that case, we can use the concept of block diagram. So in block diagram, what we will be having, it will be a pictorial representation of your entire system. So in that block diagram technique, what we do, we consider each of the elements separately. Then we determine the transfer function for each of those elements. Then those transfer function will be written in the form of block, and then they will be connected in their logical sequence in such a way that they are going to represent us the exact actual system. So they will be connected in such a way that they are going to mimic the actual system. So for that, let's take example. Here we are having a liquid level system, and in this system, this is a tank in which we have to maintain liquid level. So this level of liquid will be sensed by this float, and this float is connected to this controller, and this controller is operating this pneumatic valve that we are having here, and we will be having maybe some overhead tank which is having fluid into it that we need to maintain in this tank. So now what is going to happen if I open this of so if I open this valve, fluid is going to flow through this one in the form of output, and the liquid level will going to go down in this tank, and because of that this float is also going to move down, and the position of this float will be sensed and sent to the controller, and then controller according to this level, it is going to open this valve so that again the level of liquid is maintained to the desired level. Now this is our control system. We have to maintain the liquid in this tank. Now let's draw the block diagram for this system. So first thing, I can start with the controller, because controller is again a separate element that is used for control purpose. So what we will do, we'll find the transfer function of this controller, and we will be writing here in this block. Then that controller, what it will do, it will going to actuate this valve in order to fill this tank. So next transfer function we will be having for this valve, this pneumatic valve. Now once this pneumatic valve is open, it will going to fill this tank. So next transfer function that we will be having is for tank and now the tank level will be sensed by this float. So here for this control system, we will be having an output of this tank that will be your actual level that you desire in this tank, and that will be sensed by this float. So float is going to act as a sensor. So this signal we can connect here. So this actual level in the tank will be sensed by this float, and since controller is actuating this wall, so we can directly connect this controller with wall, and again wall is filling this tank, so we can connect valve and tank. Now next thing that we are having here, the position of float will be sensed and sent to controller. So again we need to send this signal to the controller, but before going into controller we will be having some comparator where this signal sent by float will be compared with the desired level. So desired level you will be having as a input, so that desired level we will be having as a input here. Okay, so in control system we represent this comparator as a summing point. So now after comparison, whatever input we will be having will be sent to the controller. If there is a deviation in the level, this controller is going to actuate this valve to achieve the desired level in the tank. So in this way you can represent this entire actual physical system in terms of block diagram. So what we have to do, we have to determine transfer function for this controller, transfer function of the valve, transfer function for the tank, and transfer function of the float, and we can connect them in this logical sequence. And by using concept of block diagram reduction, we can reduce this transfer function into single transfer function, and that transfer function will be the transfer function of this overall system. Now we'll discuss about the elements of block diagram. Now let's draw a standard form of control system. So we will be having input, or you can say desired input, that will go through a summing point. Then we will be having some functional block, or you can say suppose this is a controller. Then we will be having an element that it is controlling, or you can say it is a plant. Then we will be having some output, and that output will be measured by a sensor to monitor. So that sensor signal will be sent to this summing point where it will be compared, and if we are having any deviation, that input will be again fed to the controller to again control this plant. So this is a basic diagram of any control system that we can have. Now let's discuss about the different element that we can have here. So first element is a functional block. So functional block is a mathematical operation that you will be doing on an input. So here controller will become a mathematical expression, and plant is also going to become a mathematical expression. So your input is going to go through this controller and will be converted into some output, and that output will become input to this plant, and again it will be acted by that mathematical expression that we are having, that is representing this plant, and again we will be having an output. So controller and plant here will become as a functional block, and also sensor is also having some transfer function. So this is also called as a functional block. So whatever block you will be having in your block diagram will be a functional block, and it will be of course a mathematical expression in the form of your transfer function. So next element that we are having is summing element. The summing element, what it will do, it will just going to compare different signals that is going to come through it. So like here we are having an input signal and we are having a sense signal. So based on their algebraic sign, like here we are having input signal in a positive form and this sense signal may be in a negative form. So both will be compared and the resultant signal will be sent ahead. This is a work of summing element. So next element we are having is takeoff point. So takeoff point is a point from where normally we take a signal for a sensing purpose. So here we are having a takeoff point. So from takeoff point we take signal for sensing purpose. Next we are having branches. So branches are these lines that are used for connecting different blocks. So these are branches. Next element that we are having is arrow. So arrow will be indicating the direction of signal flow, like here we are having for input, direction for signal flow is from left to right. Similarly for output also we are having signal from left to right. But if you see for sensor, we are having signal which is going from right to left, so it is backward signal. Okay, so arrow is representing flow of signal. Now let's discuss about the advantages and disadvantages of this technique. The biggest advantage that we are having associated with block diagram is it is simple to construct a complicated system. So if we are having any complex system, we can easily represent each and every element by using this block diagram technique. Similarly, next advantage we are having is function of individual and overall system we can visualize. Third one we are having, based on this technique, we can determine the entire transfer function or a single transfer function that will represent the entire system. Now let's discuss about the disadvantages associated with this technique. So one of them is that it is not going to consider any physical information, or you can say constructional information of the system. It is not going to consider what type of material that system is having or any physical parameter that we are having associated with given system. So it is not going to consider that. It is only going to consider what type of physical law that system is going to follow. Next disadvantage that we are having is, for a system you may not have a unique block diagram. So it depends on the designer, so how you have created the block diagram or what are the element you have considered. So based on that, for a given system we may have a different block diagram. Now before ending, let's revise what we have discussed. We have discussed about the block diagram technique, why it is used. Okay, so it is used for a system which is complex, so we can represent entire system in the form of different element, and we will be finding transfer function of each of those element. Then we will be creating a block diagram, and each of the block will be connected in their logical sequence, and later on by applying the technique of block diagram reduction we can get the overall transfer function of the system. Then we discussed one of the practical example. After that we discuss what are the different elements that we are having in block diagram.